Hello, this is one of the introductory videos to my company, my new company called Torbellino Tech, which is a startup that basically does software. I am Juan, and this is the link to the website of the company. And in this video I will talk a little bit about the company, and I will talk what it is about, the context of the company. I have also uploaded another video which overlaps to a great extent with this one, but this is the first I'm doing in English. And I will also probably refer to that video a few times. I will link it in the end of this presentation. So, what is AI? I wanted to talk about this because it seems a lot of people are talking about this concept, artificial intelligence. And it is relevant for businesses doing software, for startups doing software. So what is artificial intelligence? I think I have studied this topic for a long time, relatively long time, let's say. And I have been listening to many different communications from different people, coming from different domains, academia, of course. I am a computer scientist. I studied computer science, so I have listened to it, and I have spent quite some time, relatively speaking, for my life, let's say, in this academia, let's say, in the education system. So I have a good sense of what people think, and I will also make a reference here, though this is just an introductory video. And I have also been listening to people from other domains, and recently, since I started this company, I have been looking quite a lot into people from many different domains and what they are saying, and also because of the public interest, let's say, or the popularity that this term is gaining. It is necessary. Seems like it is necessary to talk about it, right? But having listened to all of these things, having studied this, it seems like still nobody has been able to define it clearly. Nobody has a clear definition of what artificial intelligence is. So it is, and for that reason, I think it is an interesting question still. And I will try to maybe give some ideas how to answer the question, and I will refer to this later to some references that try to answer the question in a certain sense, in a certain way. But yeah, so Torbellino Tech, of course, as I said, is a startup. I do software. This startup is about doing software. I founded it very recently, and as I said, I think that if you want to do software, or pretty much if you want to do anything in information technology or software or tech in general, you have to, of course, you have to somehow take this into consideration. I think artificial intelligence, even if it is a complicated, ambiguous term in many ways, in many ways I don't like the term, because of that, still I think it is a good term, because it is something we have to work on, and I think it is an important term, artificial intelligence. And of course, yeah, this is one set. So artificial intelligence is one. First of all, we can say it is a set of technologies. It not only one technology, but it is a set of technologies, and a set of technologies implies that, of course, there is something that these technologies share. But for example, there is a problem with the ordering of this. What is the relationship? How can we order this set? Well, that's not so clear. There's another set of technologies that has also had universal impact in terms of reaching the public domain, let's say, and different economic impact, and has had impact in different sectors of the economy, let's say, which is blockchain technology. Blockchain mainly applied to the financial sector, right, in the form of cryptocurrencies. And so, of course, this company, again, I mean, it is only natural that I talk about this. It is only natural that I cannot ignore, right, these topics, these terms. Yes, so this is something I already said, right? This is, yeah, I think artificial intelligence in particular is a very powerful concept. I think I mean, the blockchain is a better. I think it's more clear what it is. It is simpler. For that reason, it is better in terms of science. In terms of it's a better defined concept, but still there's a lot of angles or perspectives you can have on that, especially also in the applications. I think it is still to be understood. And artificial intelligence, I think it is a more ambitious concept in a sense. It is more, in a certain sense, it is more universal, but it is worse as a scientific concept. Well, it is worse in the sense that it is more ambiguous. It is better in the sense that at the same time it is asking for some work there to be done, right? To try to explain that, or to do some research there. Yes, and I think that it could be said that artificial intelligence is among the most important concepts in the history of humanity. This has been said. Some people are claiming that, and I think it is reasonable to consider that possibility, at least, that we could be talking about something like, I mean, it's a concept, although it is still to be implemented, to be, let's say, proven in a way, but we could be talking about something similar to the internet, or to the printing press, or to the vaccine, or something like that, this type of invention. This type of impact, universal impact. So it is not just some fashion that is just you know, it's going to be here for a few years, and it's going to go away, and everybody's going to forget about that. I don't think so. I think it is going to be important. It's going to be important, maybe we could say, for the whole 21st century, or what remains of it. And there is of course some hype, some hype, just commercial hype, let's say, but it's not just that, I think. And yeah, we maybe two ways to measure this, to kind of give some objectivity to these claims. You can measure it. I think it has already had some economic impact, and also maybe the security domain, cybersecurity and beyond. There are some movements there that are also a sign that we are talking about something relevant. Maybe even maybe more clear example, just one example, but maybe it's a most clear example to get a sense of the importance of this is this is actually very recent, although it has been in development for some time already. But let's say the effect of this, impact of this is more recent. But the self-driving, full self-driving AI, artificial intelligence of Tesla for autonomous driving, I would say it's an undeniable case of this concept, this artificial intelligence. Right? It is we're talking about artificial intelligence applied to computer vision, and particular to driving. Right? This real-world artificial intelligence case, in quotes. And still early, right? We are still early. Again, for example, here it is still to be proven how this scales, how this actually functions, right? To maybe actually some people are still, I think with some reason, some logic, are still, for example, to take this case again of full self-driving, are still a little bit skeptical because this is still to be deployed worldwide, but I think it is maybe the most immediate example. There are maybe many others, maybe many others that are already in place actually, that we know about, some that we do not know about. For example, in the security domain, sometimes this is more obscure, right? But we are still early, anyways. And so yeah, as I said, yeah, many people are talking about so artificial intelligence, but there is no clear definition. So you could say, well, artificial intelligence is just the Tesla system. For example, one way to define it is a little bit like a kid, like pointing at things. Like you say, artificial intelligence is this car that is able to drive magically somehow. We just got some really big graph. Fed it at 1 million gigabytes or 1 million terabytes of data or whatever, and somehow we let it run there, and it is magically functioning. I don't know exactly what's the magic behind Tesla full self-driving. But so we are trying to get a definition, some type of scientific definition, some type of general definition, right? Not just one application, but some type of scientific definition. But in my experience, from what I have studied, and there is a typo here. From what I have studied, I have not seen. I've seen some definitions, of course, some, let's say, good enough tries, but no really satisfiable, not rigorous definition of what general rigorous scientific definition of what artificial intelligence is, and this includes also even some of the most prestigious scientific organizations or greatest companies in the world have not provided an acceptable definition. And I think there has been a lot of technological progress, in the recent decades, which is something very good. I'm talking particularly here in informatics, computer science, and related fields or sectors. But in fact, there has been almost no scientific progress in computer science, which is, I think, something. But and one of this maybe it sounds some people might sound counterintuitive, or maybe some people are not even willing to accept that. Can be a controversial claim, but so for example, one of the interesting things is that if you look at many of the developments, many of the research branches, scientific communities around computer science, is what you will find is that actually computer science, and this is I think it's quite clear also in particular in artificial intelligence. It has computer scientists have gravitated towards different domains of knowledge. For example, very clearly biology, I think, or physics. And I think this is a telling that, in fact, computer science has been unable to propose new, original, unique, distinct concepts for its own discipline. It has fed. This is, well, maybe this is a double-edged sword, right? It has, we could. It's not necessarily bad, strictly speaking, but the fact that computer science has had to somehow rely on other disciplines like biology and has taken some concepts from that, or from physics, or you can look at it from the opposite side. Physics is has also been stuck, or biology, and they are using computer science, so to speak, for their own purposes. This very fact, which in itself, in and of itself, is not something, but nevertheless, it is maybe not a proof, but it is a telling, it is a sign that computer science in itself, computer science as a distinct field, has been unable to propose new, original, unique, distinct concepts. So that is the first claim here in this slide. I think that's important to. This is a very. I understand again that maybe this is a little bit controversial. This is just one way to think about it. What I have claimed, but this is something important. This is something important because it's also important for my company because of course, the scientific element in this company is very important. It's not the only element here, but science is very important in this company, and in principle. And well, I think that this can also be, this can be controversial also. We can have different perspectives, but I think that it might be the case also that scientific understanding, scientific development, scientific discovery can imply profits. I think technology is more prone, is more, you have technological development. Technology is closer, let's say, to market. Technology is closer to applications. I understand science in itself maybe it's not that attractive, but well, I think science maybe can unlock a further technological development. Yes, I do think that. I do think there's some value there, and maybe depends on your position on the market also, right? Depends on the position of your company. Depends on your, it's a complex thing. So science, talk about science, talk about artificial intelligence, talk about references, academia, and here I just talk a little bit about Russell and Norvig. This is a artificial intelligence and model approach. It's a manual, a standard university manual. Pretty much every university in the world, more or less prestigious universities, and the top universities, let's say, in the world, in particular in computer science. And I'm talking about of course, specific professors and chairs, departments, recognized with the most recognized professors and chairs and departments in the world, reference, among many others, of course, but reference this. So it's just a reference, right? A standard university manual. And here they try to provide a definition of artificial intelligence in the first chapter of this book. In the first section, actually, the first section of this book actually is called like this presentation. What is artificial intelligence? And they try to provide an answer. They discuss different things. They dedicate some paragraphs to that, and they start from this concept of the Turing test. They reference Turing, who is one of the founders of typically considered one of the founders of this field and this concept. And they say many other things about artificial intelligence. They say, for example, so yeah, well, first I had some slides here. I wanted to before coming here, let's say, I wanted to discuss these examples, the example of to put a comparison, to compare, which it's a problematic case, and it is on purpose, to compare two scientific concepts. The concept of gold here on the left, and the concept of carrot. So we have a chemical chemistry concept, gold, on the left, and on the right we have biological, maybe, although we are going to talk about that, biological concept. And by the way, first of all, I'm not an expert. I do not claim to be an expert on chemistry or biology. So maybe I say something wrong here. I might be imprecise. Doesn't really matter. It's not. That's not the goal. It's not to be precise in particular here. My goal is not trying to be precise in this. It's just it's more about the comparison, right? I think we can, even if I'm not an expert, I think we can establish some general concepts to compare. Yeah. So basically, the point I'm trying to make here is that. So when you think about gold, I think gold, for example, gold is the typical canonical. I put it here because it's a canonical scientific concept. It is gold has been. It was defined. I don't know exactly when it was defined, but maybe it was defined. It was discovered as a scientific concept along with the science of chemistry. I don't know, long time ago, probably more than 100 years ago. I already said I'm not an expert in this, but definitely 100 years ago, and it was discovered. It doesn't matter. It was discovered. It is established in the chemical, in the periodic table. We know what gold is, and it is probably one of the most rigorous, distinct, solid concepts you can imagine, right? The point being that time will pass, 100 years, 200 years, 1000 years will pass, and gold will still be gold. doesn't really matter. It is nevertheless here it's interesting because we have apparently this photo is from a synthetically generated sample of gold. I mean, technologically, right? You have the technology to I don't know exactly how it works, but they can produce synthetically with a certain level of purity gold, right? And probably, as I said, maybe 100 years will pass, 1,000 years will pass, and the technology, I guess, the technology to synthetically generate gold will improve, and maybe 1,000 years from now they can get not only 2 nines here, but they can get 1,000 nines. I don't know, because the technology improves, they get more and more precision, but it doesn't matter because the concept of gold will still be the same. It's still the same concept, and so there is basically, you can think of it as a limit. The concept of gold and the scientific concept itself is a limit, and that limit is defined, is clear, and as technology progresses we get closer and closer to that limit, but the limit remains the same. And on the other hand, we have the concept of carrot. Carrot is a biological concept. It has a formal name, Daucus in Latin, right? It's Daucus carota. In particular, this is the wild. The Daucus carota is the wild carrot. And in particular, the one that is usually consumed and sold in the shop or in the supermarket is a subspecies, which is Daucus carota, subspecies sativus. And so there, and here is so we have I think we have. And here is the discussion. We have a biological concept, which is the Daucus carota, and the subspecies. And the subspecies, it is also a biological concept, but it is also a process of this subspecies has been generated as a process of domestication. The process of domestication, it means that humans, with human intervention across the history, I don't know, 100 years or maybe 200 years or 1,000 years or 2,000 years, I don't know exactly when this started, through agriculture, with the discovery of agriculture, and in particular with the manipulation, the application of agriculture, different techniques of agriculture across history. This subspecies has been produced, you could say, in a certain sense, artificially, to some extent, you could argue, because there is a biological, let's say, original concept, and then through this process of domestication, which is not just strictly speaking you could argue a biological concept, but there are other variables there that you could argue go beyond, which are geographical or just human intervention, different techniques of human intervention, different type, I don't know exactly. But the point I'm trying to make here is that from a methodological point of view, so for example, what is when we talk about regularity, the regularity of the concept? Why? How can we define the carrot? What is a carrot? There are these subspecies. I think when you try to characterize, again, I'm not an expert in this field, but I think that it is harder to characterize in this particular case, the carrot on the right hand as a scientific concept because of the variability, because of the complexity of the concept. I don't know, think about it, 1,000 years from now, maybe carrots have a very different or you know, how do you establish that regularity? How the concept of subspecies in itself is a little bit problematic inside biology, to put it another way. And so what I'm trying to say here by this comparison is that chemistry, from a methodological point of view, scientific methodological point of view, chemistry and biology are two different. This is just an example, but to kind of show this point, are two different types of science. And in particular, gold is one type of scientific concept, and the carrot here in particular, just an example, carrot is a different type of. And so basically, here I say the Greek degrees of knowledge. I mean, well, this is the Greeks already in the Greek culture, the ancient Greek Empire. They already established different with different concepts the different degrees of knowledge. In this particular case, I mean, we a lot of time has passed, and there has been a lot of development in many areas and many of these concepts. But basically, what I am just saying here is that there are different degrees of scientificity. So it's not just, and also the point that it takes time, because chemistry in itself was born. Going back to the case of the gold here and chemistry. Chemistry as a scientific discipline took centuries, and in the beginning it was alchemy. But alchemy, I think this was around 17th century or 16th century, the birth of chemistry. Alchemy was not in itself; it cannot be considered. This is the consensus in the scientific or the history of science, if you wish, community, that chemistry, that alchemy cannot be considered a science, and there is some point or some range, let's say, some range of years or decades in which we could say that chemistry is born as or is constituted or established as a scientific field. So the point I was trying to make here is that science is not 1 or 0, it's not black or white, but it is more complex than that. Knowledge in itself, truth in general, knowledge, science in particular, and the truth associated to science, which is a very specific type of truth, and the concept. Of course, because in science, the scientific concept, for example, the concept of goal, have a very important place. Or here, the concept of Daucus carota, or carrot. But there are still it is worth, if we want to be rigorous, to try to make some distinctions there, and in particular, to go back to the topic of discussion, because maybe we are losing a little bit track here. The point why I am here we go back to artificial intelligence. Why I'm devoting some time to this is because maybe, I think this has in a certain sense helped me, although again this is just an introductory video. When we try to approach the concept of artificial intelligence, I think it is worth to remember to try to go back a little bit, to study a little bit, even if we don't need to be experts, to study what are, but at the same time, and here's the problem, we need to, if we want to, so here's the problem, here's the complexity of the case. It is interesting, it is even necessary to go back to other disciplines like chemistry, like biology, but from a more methodological point of view or historical point of view, and not fall too deep into these fields to sort of betray our original goal, which is the definition of artificial intelligence, the definition of computer science. Because here, in fact, what I am actually saying is I am, in a certain sense, to a certain extent, I am questioning even the definition of computer science as a scientific field, and in particular artificial intelligence as one of the concepts of this field. So what I'm trying to say is, yes, it is worth to go back to think about these concepts, to think about these examples, to think about other fields, but at the same time we need to try to do it with some perspective and not lose our context, our original goal, which is to do something new, to create something new, because that is what I think artificial intelligence is. I think it is something new, a new concept. And in fact, as I was saying, although this requires maybe more explanation, and I might probably do that in other videos, I think the artificial intelligence actually is maybe the concept that is a step, an important step, a crucial step in the definition of computer science, actually, because I think that in fact computer science, strictly speaking today, cannot be considered a science, really. And artificial intelligence is the clear case of the problem here. But going back to this reference, Russell and Norvig, for example, this is telling, this is not a proof, okay, but maybe a confirmation that we are facing some problem. In fact, yeah, the authors actually accept that this is problematic, but they try to define it, and they say, what is artificial intelligence? Well, they say artificial intelligence is about learning, about perception, about playing chess, about plumbing things, about driving, about diagnosing diseases. So basically, artificial intelligence seems like can do everything. This idea maybe of artificial general intelligence, but well, if artificial intelligence is everything, it is nothing at the end of the day. Yeah. It's a too broad definition. That is not acceptable as a scientific definition, basically, is what the point here. They also say it's a science and engineering. Artificial intelligence is science and engineering. Well, maybe we have to do further distinctions. We can talk about artificial intelligence as a scientific field or as a subset of computer science, and then we can talk about the design of artificial intelligence systems. For example, if you go to policy documents, something interesting, I also now I'm looking a little bit also into policy. If you go to policy documents, like for example the AI Act of the European Union, they don't even talk. There are further documents behind them, behind this document that here they try maybe to define artificial intelligence. I am not either an expert in policy documents, but the point is, in policy documents they typically say AI systems. They talk about artificial intelligence systems. They don't talk about artificial intelligence, and it is important because if you are using artificial intelligence as an adjective here, artificial intelligence systems, the noun in systems, then this is, we're talking about an engineering of artificial intelligence. But have we already established what artificial intelligence is or not? Because if we are going to build artificial intelligence systems without knowing what artificial intelligence is, I think that is problematic also. It is doubly problematic. So, a little bit more about this reference. García and Norvig, they provide, they discuss a little bit these things, like science, engineering, and so on and so forth. They discuss a few paragraphs, and then they also provide 8 definitions of artificial intelligence, further definitions. None of them are really acceptable, because I mean they have some of these definitions are here. I talk about them. They are, let's say, a good try. They are I mean, we can appreciate the attempt, so to speak, but they are not really acceptable, because, for example, they say the problem with these definitions is basically a little bit the same with all of them, which a little bit circular definitions, because they in turn they typically define artificial intelligence as intelligence. They in the definition the same word is in the definition, which is not really acceptable, or they usually resort to human. They introduce the human element. They are artificial systems are systems that behave like humans when they are intelligent or something like that. These types of definitions and variations of those definitions, like reason, like they also they go back. So these types of definitions they are not really acceptable. They also go back to the Turing article, is the Turing test article, which is computer machinery intelligence from the mind. This was published in 1950, and they talk about that. They refer to that, and that has definitely has some historical value. And they try to reinterpret that in the face of recent developments, but it is not really. It is this by the way, this article that was published in 1950 by Alan Turing is a philosophical article. It is published in a journal of philosophy, and this is of course valuable, and it is of historical reference, and I think in fact has many, although they don't mention this, many of the sections, the last sections of the article, not the main part, but the sections. One of the good things about, so here I thought, what can we praise? What can we, of course, praise about this this article that is referenced here? Well, first of all, it is that it is a language defined. The Turing test is language defined. It is a formal approach, let's say, a formalist approach. They are introducing, it is also, as I said, it is an article of methodology of science, which means it is an approach. The most important thing about this article to understand is that it is actually not trying to give an answer, definite answer of what artificial intelligence is, or what computer intelligence is, because Turing actually doesn't talk, strictly speaking, about artificial intelligence. He talks about computer intelligence. Anyway, and the most important thing is that this is a methodological. So, in other words, how it is what the article is proposing is a method, a different method, maybe the origin of a scientific method, if you wish, to show or to try to give an answer to what intelligence is. So it is a methodological, an article of methodology of science, not strictly speaking of science. And so, also another thing is in this vein, with this goal, with this intent, I think focuses, introduces the test. The concept of test. We want to think about it. We want to think about intelligence like a test. Is another assumption. Let's say so you are introducing. I mean, you are trying to bend the discourse in a certain direction. When we talk about test, we are talking about something procedural. We are talking about operational. This is what it reminds. I think the words here are. I think it is objective. It is of course something you need to interpret. It is not science, but you need to try to understand the leitmotif, so to speak. It introduces the concept of dialogue. In order to think about intelligence, we want to think about it like a dialogue, or like a pair, or like a triad of entities. I think this is also interesting. I think this is valuable. It's something, and it has been. I think these concepts have stood the test of time, so to speak. And then they are very general, but they are something. They are a way to approach it. Then there is also answers to critics. I think this is also very interesting. There's some sections that he dedicates to argue some broad things, some general answers, from things about different. I'm not going to go into detail here, but this is also very interesting. Some digressions also, they're interesting. So this is all very good, but we have to take it into account. But I think we have to try to do something more, because this is not enough. We have to try harder, and many people have tried, and a lot of time has passed. But still, as I said, there has not been, and I think this is. I mean, you can see that, I think it is a problem in the community that there has not been a definite scientific answer to what artificial intelligence is. And so, in this context, I mean, this is an introductory, just an introductory video. I have other videos in my channel, but this is the first I do in English, and I think it was necessary. So I am in this context, with this thing in mind. I think it is important to try to give a definition, and actually I think that artificial intelligence, it is a concept that is asking for definitions. It is asking for actually various definitions, and here I well, I already have it, but this is a lecture that is live. Is a live. I am testing the concept actually. As I said, this startup is new. I am testing the service, how to actually provide the service. But I am now offering a lecture, a live lecture that you can book, in which I provide one definition. I attempt to provide one definition of artificial intelligence that is a historical definition. This is the first lecture in a series of lectures I have in mind, and this is the historical definition of artificial intelligence. And why a historical definition of artificial intelligence? Well, first of all, I go back to what I said before. There are different degrees of scientificity. I put the example of chemistry and biology. These are, chemistry is maybe undeniable, the undeniable case. It's like the canonical science, maybe what we all should strive for when we are trying to do some science. Biology is a good case, although it's a little bit problematic. I already talked about it. And then history. I provide here a historical definition of artificial intelligence. History. What is history? Well, I think, so first of all, this is not, strictly speaking, this is not a scientific definition. So I am honest with you, let's say from the beginning. I am not here in this lecture, strictly speaking, attempting to provide a scientific definition, because strictly speaking, history is not a science. This is also one of the maybe principles, or how I think about it, one of the principles of this company. History is not a science, strictly speaking. Of course, again, there are different degrees of scientificity, and there are different degrees of truth, let's say. And I think, even if I am already being honest from the beginning, telling you, I think this is also valuable in itself, telling you that this is not a scientific definition, I am telling you this is a historical definition, and I think this definition is valuable. And I think, also I think this is maybe a necessary step before trying to embrace the task of providing a scientific definition, rigorous scientific definition of artificial intelligence. First, we need, so to speak, we have a meeting, so to speak, with history. We have to do some work with history, also in a negative way, so to speak, negative, let's say logical negative way, because one thing from history, even if history is not a science, one thing we can learn from history is what not to do. I think this is also valuable. So here in this lecture, I think this is interesting. I provide here a historical definition of artificial intelligence. I think this is unique, a unique service. Probably I don't think you are going to get, or at least not with the same clarity. You are not going to get anywhere in the world. I think you are not going to get the type of knowledge I am providing here in this lecture. This is I have not seen in any of the books in any of the things, and I have read, I have listened to, I think a highly representative sample of definitions or attempts or different people, different domains, and I have not seen anywhere from what I have studied, as far as I know, as far as I can go, let's say, I have not seen anywhere this type of knowledge, and this is why I think this, not only because it is unique, but I think it is also correct to some extent, of course. I think you will be able to appreciate the value of this lecture, although also I should say, maybe you have already imagined that, you have that intuition, this is maybe a niche, maybe a very niche service. It is maybe it's only interesting for a subset, a relatively restricted subset of people. And so yeah, also this is a work in progress. I have already mentioned that, and I think, again, to stress that I think it is useful to have a definition, or to try to have a definition, to try to have a scientific definition. So, for example, it might explain many questions. I mean, has some impact. Also, it's not just let's say some kind of I don't know how to say it. Some kind of diversion, some kind of purely scholar academic diversion. I think there might be, I'm sure of that actually, that there is some usefulness, some utility that we can gain from trying to do this. We can explain many questions around this concept of artificial intelligence. What are the economic consequences or limitations of automation, for example, right? This is complex thing, and trying to do this, I mean, going through these trials, let's say, through these obscure things can help trying to order that. And we are trying to attempt generalization to other sectors, to other cases. Well, I think there is some value, and I hope you can appreciate it. And yeah, I think here I also refer to my I already talked about it. I have this my YouTube channel, the YouTube channel of the company, where I have uploaded other videos. I refer here to the Principios Uno. This is a video in Spanish. This is a Spanish-based company. I am Spanish. I am from Spain, but I also I'm working here. I'm working on an English version, probably soon, to translate. Actually, I think I'm. Yeah, well, here I talk a little bit about what I said. I also talk a little bit about other things. Anyway, I will maybe review that and see what I do. But anyway, that was basically what I wanted to say. You have here, maybe I will upload this. I mean, you have the information anyway. You can have all this information. Well, not all of them, but not all of it. But you can get information here in this link for the company. You can get there the YouTube channel and many other things. Booking the lecture and whatever, and you also have there my email. You can contact me there. My email is not here. It should be here actually in this slide, but you can find it here anyway. That was it. Maybe I hope I will be publishing more content very soon.